Okay, it's time to get started with our live lecture. Hello everyone, my name is Isaac and I'll be the lead instructor for today's lecture. And the topic today is going to be database foundations in NoSQL. Okay, so let's go ahead and let's talk about what is NoSQL. Okay, and NoSQL is a specific kind of database. Okay, we are going to be using a specific type of NoSQL database called MongoDB. Okay, so let's go ahead and navigate to mongodb.com and see we have the official documentation here for the MongoDB service. We're going to be using this today to facilitate operations in our database. Okay, another thing we're going to be learning about is MLab. Okay, and if you don't have MLab, you'll need to sign up for a free account. So make sure you do that, mlab.com. And MLab is going to be our cloud provider. Okay, so it's not ideal these days to keep databases on your machine just due to the risk of the loss. So it's better to use a cloud service to host your data instead. So that being said, we're going to use these couple tools. So let's go ahead and let's talk about the structure of a NoSQL database, okay? So first, let's start by creating one. So in your MLab account, we'll go ahead and create new. And from here, we're going to choose Amazon as our cloud provider and Sandbox for the free version and continue. Okay, and I'm going to choose the region nearest me and continue. Then I'll just call this Coder Camps DB and continue. Everything checks out here, so we'll submit the order. And, oh, it's not available. Okay, let's try a different name, okay? So go back, and I will simply say this is Coder Camps database instead of DB. See how that works out for me. All right, it worked that time, okay? So we click on our database. We can see that we have 4 tabs down here, okay, or 5, I should say. So this first tab is called collections, okay? So what a collection is within your database, you're going to have subcategories of certain kinds of data, okay? So as you can imagine, a big site like Facebook would have users data, but it would also have posts data, okay? So they need all of the data in their database, but they also need it to be separated, okay? So this is how we're going to separate our data using different collections. Okay, and within each of those collections, there's going to be individual records referred to as documents. Okay, and these documents are stored in Bison, which is very similar and translate to JSON, to where we can access each of these properties using things called fields. Okay, and fields are the characteristics of each document. So now we understand the overlying architecture of the database. Let's go ahead and let's talk about users, okay? So database users are different from account users. So as you can see, the account user is myself, but maybe, this is a company database instead, right? And so for the database users, they don't want to just give access to anyone in their, affiliate, their company. They only want to give it to very specific users because data is very precious and it tends to be, what makes or break a company. So that being said, let's add a database user so we can authenticate. So I'll call this one Isaac, and I'll just give it an easy password for now, 123, keep it simple, and we'll go ahead and create that one accordingly. All right. So from here, let's go ahead and let's connect to this database, okay? And how we can do this is we're going to be using the Mongo shell. So, when you install MongoDB, you'll get the Mongo shell installed. And it's going to allow us to communicate using our own computer, communicate with our database here in the cloud, okay? So how we can do this is I'm going to be using this connection here, say how it says connect using the Mongo shell. I'm just going to copy this and paste it in accordingly, okay? So Let's go ahead and copy, come to our command line here, and I'm just going to paste that in. But before I hit enter, I need to change out a couple of these values. So the first one is database user. So I named that Isaac, okay? And if you remember, I named my password 123. So I'll pass that in. And now I made those edits, I will hit enter. And as you can see, using the Mongo shell, it has connected to my database. So now I have ability to communicate with it. But not only communicate, I can actually perform operations such as reading and writing. So let's go ahead and let's explore those. So first things first, let's create a collection, okay? So where we can insert some data. So inside of our MLab here, I'm going to add a collection, and I'm going to call it cars, okay? And as you can see here, it has 0 documents at the moment. So let's insert some documents into this cars collection, okay? How we can do this is we're going to say DB, and then we target the collection, which is cars, and then we pass in the command which we want to run. Okay, so in our case, it is insert one, and we just need to pass in an object form. Okay, so I'm going to pass in a year and a brand, or let's do a type and year. Okay, so we'll say type. And let's go ahead and make this Tesla, and comma. From here, we'll go ahead and pass in year, and we'll make this 2017. Okay, so from here, let's go ahead and hit enter. And as we can see, when we say acknowledge true, that means success. Okay, so if we go back to MLab, we refresh, we can see now we have a cars collection with 1 document. So we click on that, and we can see that it saved Tesla with the year 2017, and then it automatically generated this unique ID for us. Okay, and this is one of the best parts about MongoDB is that we have these unique identifiers to separate all of our different documents. Okay, so maybe if we have 2 Teslas, right? We can still separate them because they're going to have different IDs. So that being said, let's add a couple more cars to our collection just to get the hang of it. So we'll say db.cars.insert another one, and let's go ahead and make this a type of Mercedes. Okay, we'll give it year of 2000. Okay, insert that, and then let's add one more, db.cars.insert one, and we'll make the type BMW, oops. And the year, let's make that 2006. Execute. Okay, so now we should have 3 cars inserted in our database. So let's go to our database and refresh. And as we can see, we are getting the cars, inserting accordingly. Okay, so now let's talk about how we can retrieve these cars and we can read the data that's in our database. Okay, so it depends on what we want to read. Okay, so let's start with just reading all cars and retrieving everything. Okay, so the operations that we're performing right now are commonly referred to as CRUD. So we just performed a create operation, and now we're performing read. And then the other 2 common operations with our database would be update and delete. So knowing that, let's go ahead and let's return all cars by saying db.cars.find. And then we can pass in some sort of filter to filter out certain cars with maybe certain types or years. But in this case, we're just going to retrieve them all. So I'm going to just pass in this empty object and execute. Okay, so as we can see, we're getting, the nice values, okay, just as we expected, and printed out accordingly for all of the records in the cars collection in our database. Okay, So now let's talk about how we can find documents by equality, okay? So what if I want to find a car with a type equal to Tesla? So if I wanted to do that, I'd simply type in db.cars.find, and then I'd pass in my EQ, okay? And this is my equivalence filter here. And I would say type is equal to a Tesla. And then if it is, it will return those records. But if it isn't, it will ignore them. Okay. Let's see. Did I close out? Nope. Looks like I closed my bracket here. Good there. Okay. Oh, yeah, I did. I mixed up my my order of operations here. So I can say db.cars.find, and then I want to pass in type, and the type is going to be equal to the year or the type of Tesla. That's right. Okay. So this is our proper layout here. So we execute. And as we can see now, this query is only returning one item. It's returning just that Tesla, okay? Because these other two do not match, this equivalence, so it doesn't return them. Okay, so now let's go ahead and let's talk about how we can query using comparison operators. Okay, so what if I want to find all the cars, that are above, let's say, 2005, but they're below 2010. Okay, so let's see if we can get that return. Okay, so I'm going to say db.cars.find. Then I'm going to pass in greater than year 2005. Okay, and then I can simply pass in a comma here, and I can specify my less than setup here. Okay, so I'll say less than year 2010. Okay, and then we just have to close this off. And so now it's going to look for all cars the year greater than 2005 and less than 2010. In this case, we only have the BMW, which matches that criteria. So let's execute. And looks like I left something out here. Okay, so we got year. I believe everything looks good here. Oh, I'm trying to do these both at once. Yeah, getting ahead of myself. Okay, so let's just do one at a time, and then we'll talk about how we can do multiple. Okay, so let's find year greater than 2005. Okay. Fine. Oh, I keep mixing that one up. Okay. We need to find the year whose bling greater than 2005. That's correct. Okay. So as you can see, it returns all the cars with the year greater than 2005. So let's go ahead and let's try this with less than. Okay. So db.cars.find, and then we'll pass in year and pass in less than, and the year, let's pass in 2010. Okay, and we execute, and we can see that, it only gives us the cars, whose year is less than 2010. Okay, so now we've seen how comparison operators work. Let's talk about some logical operators, okay? And this goes back to what we were trying to accomplish a minute ago, is combining these conditions using an AND operator, okay? So to use the AND logical operator, let's go ahead and find all cars between the years 2005 and 2010. So we'll say db.cars.find, and then we pass in bling and, Okay, and then the value is going to be this array. Okay, and then for the specific setups here, we just need to pass in the multiple conditions. So in our case, it's going to be greater than less than. Okay, so we'll say year, and then we'll pass in greater than, and we'll say 2005, and then let's go ahead and put a comma here, and we'll go ahead and say year is going to be greater than 2005, or 2000, less than. We already have greater than. Less than 2005. Okay, close, 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 oops, close, close, close. Okay, I think we got that close off correctly. So now let's execute. Yeah, I think I have an error, but I think my brackets are a little off here. Well, finding and year. Oh, I put years less than 2005 here. I should have put years less than 2010. So I'm just going to come in here, and I'll say years less than 2010. All right, there we go. So as we can see, the only record that was returned was the BMW, because its year is greater than 2005, but it's less than 2010. So using this AND logical operator, we were able to combine those expressions and get this outcome. Alrighty, so let's do the same thing for OR. Okay, so let's say we're looking at our database for a BMW or a Tesla, either or. Okay, so if we were gonna set this up, we would say db.cars.find, and we'd start by passing in OR, and inside OR we would just pass in our conditions. Okay, so I'm gonna say if the type is Tesla, close, type Tesla, okay, comma, or actually, type Tesla, comma, or type BMW. Okay, now we can close this off. Okay, so now when we execute this, we can see that the only records returned are a Tesla and a BMW. And that's because, it found the records that matched either one of these. Okay, so those are the AND and the OR logical operators. Okay, so now let's go ahead and let's find, or let's talk about projections. Okay, so projections are a way of only querying data you need. And this is very handy in a lot of ways, because a lot of times we don't need every single aspect about that document to use, right? Maybe we only need to display the username or the type of car, right? So if we're going to do this, we can use projection instead of just querying the whole thing, and this will help with performance. So let's create a projection. So I'm going to say db.cars.find, and then how projection works is I'm going to pass in an empty object. So I find all, and then I'm going to specify which fields I want, okay, which fields I want to query. So in this case, let's just get the type, and then I'm going to pass in 1 or 0, and 1 means true and 0 means false. So I'm going to pass in 1, and we'll just close this off, And I spelled cars with a Z. Cars.find. Let's try that again. Empty brackets here. And then we'll pass in type 1. Okay. And with the parentheses field. Okay. So as you can see, it targets all of the cars, but only returns the type. You'll notice we no longer have the year there. Maybe we don't need the year, right? You notice by default though, it does return the ID. Okay. So if you don't want that, you can remove it with a protection. Okay. So we'll say db.cars.find empty. And then we will pass in type equals 1 and underscore ID equals 0. Okay, close that, and we close that. Okay, so now you can see, because I passed in false, it ignored that, and it only looked up the type, and that's all that was returned to me for all cars, okay? And it's a great habit to be in. Only query what you need and nothing more. Okay, so now we've talked about how we can create data and how we can read it using all these great different query methods. Let's talk about how we can update and delete data as well. Okay, so let's start with updating. So I'm going to go ahead and change maybe the year. So I'm going to say db.cars.update 1. I'm going to use the bling set operator here to set new values. Okay. So, actually, let me target what I want to change. So I'm going to change my Tesla. Okay. So type equals Tesla. And I'm going to use bling set a new value. Okay. So the new value is, we will pass in the year, and let's make it 2018. Okay, maybe we're adjusting from last year's model to this one's. And then let's go ahead and close this off. We're going to pass in what's called upsert. Okay, and this basically means to, upsert the values instead of replacing the whole object. Okay, so now it's going to look for all the Tesla types and set the value of the year on those to 2018. So I'm going to hit enter here. No, what did I do this time? Okay, so yeah, I don't think I closed off my my brackets appropriately here. I think there's one missing at the end. So let's just go ahead and paste that in. And before this curly bracket, I'm going to put another curly brace because I believe that's what I'm missing. Okay, invalid property ID. Cannot, okay, set year. Oh. Yeah, let's try to target the Tesla type. Okay, so give me a second here. Let's put some quotes around type here. Okay. Looks good here. Still doesn't like ID. Invalid property ID. Cars to update 1. I don't think we're using ID here. Okay. Let's see. We're setting the value. That looks good. Let's just try this from scratch. We'll see. db.cars.update 1. And we'll pass in a type. And this is going to be equal to Tesla. And then we will pass in our bling set operator. and we'll pass the year of 2018. Okay, and then we will simply pass in our upsert statement equal to true. And then let's go ahead and end the parentheses here. Okay, perfect. Okay, so as we can see, it modified it. Okay, we can see it has a modified count. So let's go from here and head over to our MLab and refresh. We can see that Tesla has gone from the year 2017 to the year 2018. So that's how we can update data, using Mongo. So now let's talk about how we can remove data. Okay, so let's go ahead and let's say db.cars.delete1, and then we're going to pass in the specific filter. So maybe we want to delete the BMWs. Okay, so we'll say type is BMW. And then we will close this off and we will execute accordingly. Okay, so it says it was deleted. So we go to our MLab, we refresh, we can see that we no longer have any BMWs. We targeted those and deleted them with our method here. Alrighty, moving right along. Let's talk about indexes. Okay, so indexes are really useful because they're a copy of documents, and they allow you to query them faster. Okay, so whenever you find yourself querying the same, fields over and over again, go ahead and set up an index, and this will be even faster. So let's go to our MLab, and if we look, we have an indexes tab here, and as we can see, it's just this, simple default index, right? And it's always gonna have ID as an index because this is gonna be something you're gonna be querying a lot. So it just sets that up for you. But maybe there's another field like type that we are gonna be querying a lot, so we can set up an index for this. Okay, so let's go ahead and let's create our index by saying db.cars.create index. Okay, and then we're going to pass in the type and the year. Okay, so let's go ahead and pass in type. We'll say 1 for that. 1 equals true, and the year. Okay, and we'll say 1 for that. So because those are both true, they'll be added to the index. Let's go ahead and execute. And as you can see, it updated that accordingly. So now we go, let's refresh this. And we can see now we have an index set up for the type and the year. So now we can query these even faster than we did before. Okay, so now let's talk about one-to-many relationships and how we can set those up in our database. Okay, so a one-to-many relationship is just how it sounds. Facebook's another great example of how this works. Okay, so you're one user, and one user has many posts. Okay, so because of that, there's a relationship there. So let's create a similar relationship in our own application here. Okay, so let's say we want to relate a bunch of places to a category, right? Similar to like Yelp or one of those services. So to do this, let's go ahead and let's start off by creating our different categories. Okay, so I'm sorry. Let's start with places. I'm going to go to our MLab here, and let's add a couple new collections. We'll call this one places, and we'll call this one categories. Okay, so now we have places and categories in play. Let's go and add to them. So I'm going to insert some data for places by saying db.places.insert, and then I'm just going to give it a name, and we'll call it Disneyland. Okay, and then let's go ahead and close this off and insert that accordingly. Okay, so let's insert another one, db.places.insert. And for the name, let's go ahead and pass in Universal Studios. Okay, and then let's pass in one more. We'll say db.places.insert. And let's make it a different category, right? Disneyland, Universal Studios, those are very entertainment. So let's make like a food one. Okay, so I'm going to say db.insert name, and we'll say In-N-Out Burger. Alrighty there. Okay, so let's look in our database. We refresh, and we can see that we have the 3 different places created. So now let's go ahead and create our categories and relate, the places accordingly. So for categories, we can say db.categories.insert. Okay, and then I'm going to go ahead and insert a name of the category. So maybe I'll call this entertainment. And then from here, I just need to give it a, the places related to it. Okay, so I'll say places. Then I'm going to make an array, and I'll say Disneyland. And let's go ahead and comma, and also throw it in Universal Studios. Okay, and those are all the entertainment places. So I'm going to go ahead and close this off like so, and let's hit enter. Okay, so we've added one category for entertainment. So let's add the other one for food. So we'll say categories.insert, and then the name of this category will be food. Not good, food. And then the places related to it are going to be In-N-Out Burger. Okay, so now let's close this off. And from here, let's go ahead and add this second category. Okay, so now if we go and we refresh, we can see that we have 2 categories. Okay, and we have 3 places. What's great is we've just created a one-to-many relationship between all of these. Okay, so now all I have to do is a single query for the entertainment, and I'm going to be given all the places related to that. So I don't have to make multiple queries to different collections. And the same thing for food. So let's go ahead and give that a whirl by getting the data for our entertainment category. Okay, so what I'm going to do is I'm going to say db.categories.find. I'll pass in name equal to entertainment. Okay, close off. Okay, so as you can see, it only pulled up the places associated with entertainment. Okay, because I have my one-to-many relationship set up. So I can do the same thing with food. I'll say db.categories.find, and I'll pass in the name of food. And then from here, we can go ahead and we can close it off. And as you can see, it finds In-N-Out Burger, right? It finds all the places associated with food. Okay, so that about wraps it up for today's lecture. At this time, I'm going to go ahead and open up the floor for anyone who has any questions. No questions today? Okay, so if there are none, we'll go ahead and conclude this. Thank you, everyone, for joining. Have a great day and happy coding.